Hello and welcome to the new lecture session of modern vehicle technology. So students, today we will discuss on a new topic, that is hybrid vehicle. This is another topic of modern vehicle technology. So let's start the hybrid vehicle. A hybrid vehicle uses two or more distinct types of power, such as submarines that use diesel when surfaced and batteries when submerged. Other means to store energy include pressurized fluid in hydraulic hybrids. Basically, it is a vehicle which uses both electricity and fuel injection in order to run. As you can see in the picture, there are three types. One is conventional, which is we normally use. Then is battery electric vehicle, and the combine of these two things means conventional vehicle and electric vehicle, hybrid electric vehicle is generated. Where in the conventional fuel, where the fuel enter the engine and power is produced in the engine, then it goes to the transmission. And the battery in electric vehicle, where battery helps to run the motor or generator, then motor or generator sends the power to the transmission to move the vehicle. And in the hybrid electric car, there are two types are two both are used, whereas electricity, that is battery motor generator to transmission, and the conventional fuel injection, where fuel engine and then transmission. So basically hybrid electric car, so students, are basically hybrid vehicle or hybrid electric car is a combination of both conventional vehicle and electric vehicle. Now also the history of this hybrid vehicle. The first hybrid car was built in the year of 1899 by the engineer of William H. Patton, who patented an application for a gasoline electric hybrid rail car propulsion system, or and for a similar hybrid boat propulsion system in the year of 1889. In the year 900, Ferdinand Porsche, who employed at the Lohner coach factory, developed mixed a four-wheel drive series hybrid version of the system Lohner Porsche, which is appeared in 1900 Paris World Fair. Then, in the year of 1901, George Fisher sold hybrid bus to England. In 1902, Knight Naftel produced a racing hybrid vehicle. In the year of 1905, Henry People introduced a hybrid vehicle with an electric motor, a generator, batteries, and a small gasoline engine. And in the year of 1931, Eric Geissen invented and drove from Edinburgh to Berlin at a half horsepower electric car, which is containing features later incorporated into the hybrid car. So basically In the 1931, the hybrid car was introduced. Now, in the year of 1960, the US or United States was introduced legislation that encouraged greater use of electric vehicle in the attempt to reduce the air pollution. While the government tried to garner support for hybrid, renewed public interest did not gain movement until the Arab oil embargo of 1973. The oil crisis caused the price of gasoline to soar while supply fell dramatically. In those days, nearly 85% of all workers drove to work due to the gas prices and the declined supply were a major concern. So that's the reason. So that is the reason of the rebirth of the hybrid vehicle. So in 1999, the Honda Insight became the first mass production of hybrid vehicle released in the US. The two-door, two-seat Insight may have been first, but it was the Toyota Prius sedan released in the US in 2000 that gave hybrid technology the foothold it was looking for. In the years since its US introduction, the Prius has become synonymous with the term hybrid. It was the most popular hybrid vehicle ever produced, and auto manufacturers around the world have used its technology as a basis for the countless other vehicles. So students, these are the basic history of the hybrid vehicle. So students, here we will discuss the key components of the hybrid electric vehicle. So first, let's start with this battery. In an electric drive vehicle, the auxiliary battery provides electricity to start the car before the traction battery is engaged, and also powers vehicle accessories. Next is DC-DC converter. This device converts higher voltage DC power from the traction battery pack to the lower voltage DC power, which is needed to run the vehicle accessories and recharge the auxiliary battery. Next is electric generator. The electric generator generates electricity from the rotating wheels while braking, transferring that energy back to the traction battery pack. Some vehicles use motor generators that perform both drive and regeneration functions. The next is electric traction motor. The electric traction motor is using power from the traction battery pack. This motor drives the vehicle's wheels. Some vehicles use motor generators that perform both the drive and the regeneration functions. Next one is exhaust system. The exhaust system channels the exhaust gases from the engine out through the tailpipe. A three-way catalyst is designed. A three-way catalyst is designed to reduce engine out emissions within the exhaust system. Next is fuel filler. A nozzle from a high pressure dispenser attaches to the receptacle on the vehicle to fill the tank. This next is fuel tank. This tank stores gasoline or fuel on board the vehicle until it's needed by the engine. Next is IC engine. Here we discuss on spark ignition engine. In this configuration, fuel is injected into either the intake manifold or the combustion chamber, where it is combined with the air, and then the air fuel mixture is ignited by the spark from a spark plug. Next is power electronics controller. This unit manages the flow of electrical energy delivered by the traction battery and controlling the speed of the electric traction motor and torque which is produces. Next is thermal system cooling. This system maintains a proper operating temperature range of the engine, electric motor, power electronics and the other components. Traction battery pack stores electricity for use by the electric traction motor. Next is the traction battery pack, which is used to store the electricity for use by the electric traction motor. And the last one is transmission. The transmission transfers mechanical power from the engine. Transmission power transfer mechanical power from the engine and or electric traction motor to drive the wheels. So student, these are the key components of the hybrid electric vehicles. Next one is the classification. The hybrid vehicle can be classified basically in two ways. First one is types of powertrain and second one types of degree of hybridization. There are three types of powertrain. First one is series hybrid, second one is parallel hybrid, and the third one is series parallel hybrid. And in case of types of degree of hybridization, there are two types. One is mild hybrid and another is full hybrid. So students, let's start with this series hybrid. The traction power is delivered by the electric motor, while the IC engine or internal combustion engine via a generator produces electric power to drive the electric motor. The excess power is then stored in the battery pack. The IC engine or internal combustion engine is decoupled from the driven wheel and can be operated mostly in the maximum efficiency region. The major shortcomings of the series hybrid driven chain configuration are the high power installation in each component and the request of the generators. In fact, the energy from the internal combustion engine is converted twice before the drive the wheels. Thus, this system is more expensive than the parallel one. In the figure, this is the engine, this is generator, this is used as an inverter, this is the battery, this is the electric motor, and this is the transmission, and this is the wheel. So here, from the IC engine, power which is produced from the power produced from the engine goes to the generator, the generator to inverter, and the inverter to the motor and the series. In similar way, this electric motor can be also get the power from the battery. So in this way, the power is drive to the vehicle, and then the drive to the wheel, and then the vehicle is moves. So that's why this is called the series hybrid. Next is parallel hybrid. There is direct mechanical connection between the hybrid power unit and the wheels. In addition, this layout has an electric traction motor that drives the wheel and can improve a share of the braking energy in order to charge the batteries. Regenerative braking or help internal combustion engine during the acceleration condition. In fact, internal combustion engine and electric motor are coupled with a mechanical device. There can be a torque coupling with a single shaft or two shaft configuration, a speed coupling with the planetary gear unit, a merge of both previous coupling. So students, in this figure, the vehicle is getting power from the engine, from the internal combustion engine directly, and the electric motor, also the electric motor. So here the power line is in this way, up from IC engine to the transmission, then transmission to the gear, and then to the vehicle. And another way is battery to the inverter, inverter to the motor, motor to the gear, and then the wheels. So basically, in this mechanical device, which is getting the power from the both sides, one is IC engine and the electric motor. That's the why this is known called parallel hybrid. Next one is series parallel hybrid. The series layout and the parallel layout are merged together in order to have both advantages. In particular, the IC engine or internal combustion engine is able to supply the electric motor or supply the electrical motor or charge the battery bank battery thanks to a generator. In this picture, IC engine, internal combustion engine, to the power transformed to the planetary gear. From planetary gear, it goes two way, and directly with this mechanical device, and then comes to the wheel. Another is planetary gear to the generator. Then generator to the goes to the inverter. And another way, battery comes to the power battery to inverter, then inverter to the electric motor to the mechanical driven live line drive function, then the wheels. So in that case, there are a combination of series and parallel both. If we think the line is going this way, engine, then planetary gear, then generator, then inverter, another battery, inverter, and the motor, and then comes the transmission. So this is the series. And if we think engine, planetary gear to the transmission, and another way is battery, inverter, motor, and then the transmission. So this is the parallel. So here this is the combination of both. That's why this hybrid is called as series parallel hybrid. So up to we will discuss the three types of hybrid vehicle according to the powertrain. Now comes to the hybridization. First is mild hybrid. The electric motor generator, the electric motor generator in between engine and the transmission. Here electric motor or generator placed in between the engine and the transmission section. The armature or rotor of the motor actually replaces the engine flywheel in many designs. The internal combustion engine and the electric motor share the same shaft, so one cannot turn without the other. This means the mild hybrid cannot have the electric launch feature of the full hybrid. The electric motor cannot turn the wheel independent of the engine. It can include all the other features of full hybrid regenerative braking, ideal stop, and a downsized engine. The GMC Sierra pickup and Honda Civic or Honda Accord are the mild hybrids. So students, here are the vehicles. This is the GMC Sierra pickup, GMC Sierra pickup vehicle, which is the mild hybrid vehicle. This is the Honda Civic vehicle. This is the Honda Era vehicle. So these are the pictures. These are the pictures of the mild hybrid vehicle. So students, today we learn the definition of the hybrid vehicle, its history, working principle, key components, and the types of the vehicle. And the rest of the types, basically full hybrid vehicle according to the degree of hybridization, which will be discussed on the next class. So till then, stay at home and stay safe. Thank you so much.